Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the June 2024, the R paper, which I guess is the regional paper or the replacement paper. Okay, so it's like the alternative in June 2024, maybe for regions, because of the problem with, like, what's it called, leaks and so on. All right, so there's a regional paper, so it's different from the normal June 2024. There's a different variant, basically. So it says the table shows corresponding values of x and y for a continuous curve with the equation y equals f of x between x equals -4 and x equals 5, where a is a constant. That's a. The a value is basically missing here. The trapezium rule is used with all the y values in the table to find an approximation for the integral between -4 and 5 of f of x with respect to x. We're told that the value of this approximation is basically 19.3. We got to find the value of the constant a to 3 significant figures. Okay, so the trapezium rule is basically when you make an approximation for the area by basically, in this case, it's going to go from -4, so we can move that here. All right, so basically, let's just say this is our curve. Let's do something like this, for example. All right, and say this is where you got -4 and then -2.5 and -1 and so on. So basically, you have these values of y. So there's a value of y here and there and there, and over here, for example, and so on. So you have all these different values of y for these x values, which form, if you were to join the tops of each of them together, like if I joined that to that, it forms like trapeziums, these small little trapeziums. And when we find the area of each of these individual trapeziums and add them together, it gives us basically the area of the curve between those values, or the area under the curve between those values. It gives us an approximation for that. Okay, so you find the area of this trapezium plus that trapezium and so on, and they're all supposed to be equal widths, as we can see that they are. Each of these is 1.5. So the width between -4 and -2.5 is 1.5. So -2.5 and -1 is also 1.5, and so on. So each of these are of equal width, so that you got all these equal width trapeziums. You add basically all the areas together, and it gives you an approximation for the area. And they told us that the approximate area is 19.3. Okay, and with that we have to find the value of a. So basically what happens here is when you find the area of a trapezium, you know that the area of a trapezium is given by, the formula normally given is in this form, half times a plus b times h. I like to think of it as the distance between the parallel side, which is h, which would be these distances here, okay, which is the width here, divided by 2 times the sum of the parallel sides. That's the area of one of those trapeziums. Now, if you think about it, the first trapezium, A and B are the parallel sides, these ones that are going vertically here. So this would be the area for the first trapezium. You're going to use this length and this length, or your A and your B. For the second trapezium, you're going to use this length again, and then this length. So this length has been used twice now. For the third trapezium, this length and that length. So again, this is used twice. And for the next trapezium, this length and that length, and so on. So all the ones on the inside, all these ones here on the inside, their length, that length is used twice. Okay, that length is used twice. So this first one, so all the ones in between, sorry, the length is used twice. Let me get rid of that first. So all of these ones here, the length is used twice, but the ones at the end, these two lengths, they're only used once, the beginning at the end. So basically, the area of this is given by the formula. You have the area is h over 2 times, and you have, for example, you call this y1, and you got yn, the last one. These two are used once, and then you have plus 2 times y2 plus y3 all the way to yn minus 1. So basically, all of the ones on the inside, from the second one to the one before the last, they're used twice, but the first and the last are used just once. So this is a kind of like a formula, which you have in the formula sheet anyway, but you don't really need to use it if you understand this very carefully. So basically all we have to do now is we say that the area of the trapezium is given by the distance between the parallel sides. As we said, it's 1.5 divided by 2 times the sum of the parallel sides. So you've got to have this represents the y value of these points here. So that's 4.1.6, 4.16, 2.91, and so on. So we're going to use the first and the last one time. So 4.16 plus 2.28. And then you add to that 2 times, and you're going to have to add these together. So it's 2 times all of these added together. So you have 2 times 2.91 plus a, which is what we have to find, plus 1.73 plus 1.37 plus 1.43. Close the brackets, and that's going to equal 19.3. That will approximately give us 19.3. Okay, to 3 significant. Okay, we've got to find 8 to 3 significant figures. So that the value of the approximation is that. So you can see the only thing we don't know is this a. All right, so let's just sort out all of this. Let's see. I can multiply both sides by 2. So I have 1.5 times. Let me add these together at least. Just sort this out. So you have here 4.16 plus 2.28. 2.28. That gives us 6.44. So this is 6.44 plus 2 times, and I'm going to add these together. So you're going to have a plus, and then the sum of those. So that gives us, let's put this over here so we can see, 2.91. So you have 2.91. Careful. Plus 1.73 plus 1.37 plus 1.43. Okay, so that gives us 7.44. So a plus 7.44, and close that bracket, and that's equal to, and remember I multiplied by 2, so 19.3 times 2, so 19.3 times 2, that's going to be 38.6, that's right. Okay, so now what we can do is we can divide both sides by 1.5. Let me do that as well. So this becomes divided by 1.5, which is going to give us 25.733. Let me just write it as 386 over 15 for now, just to keep it more exact until the end. So now we have 6.44 plus 2a. In fact, what we can do is we can subtract 6.44 from both sides. So I'll put minus 6.44. That's going to be 2 times a plus 7.44. Okay, so now we have 2 times a plus 7.44 is equal to, let's calculate this before we move on. So you have 386 over 15. Take away 6.44. That gives us 1,447 over 75. Is that right? Yep. And now we have to divide by 2. Okay, so we have a plus 7.44 is equal to, that's going to be 1,447 divided by 150, because if you divide that by 2, you get 150. And then we're going to take away 7.44 from that. So let's just write that's going to be, so you divide this by 2, dividing both sides by 2, and then take away 7.44, and we end up with 2.206 recurring. So 2.2066 continues on like this. So they want the answer to 3 significant figures, so it's 2.21. So 2.21 is our answer, the value of A. And that completes this question to part A. this paper and we'll move on to part B. It says use the given answer of 19.3 to find an approximate value for 2 times f of x minus 3 with respect to x. So basically what we have here, we already know that between 5 and minus 4, the integral of f of x with respect to x is 19.3 approximately. Okay, so we want to use this answer to solve this problem. Okay, so what we need to do here is we need to rewrite 2 times f of x minus 3 in terms of just f of x and with the integral. So the first thing I'm going to do is I'm going to use the fact that if you have 2 separate things that you are, 2 separate functions that you have f of x plus g of x. 2 separate functions that you are integrating. You can integrate each of them separately. So I can write this as f of x plus the integral of g of x, both of them with respect to x, and it's the same thing. So I can think of this 3 as a separate function if you want. So you can write this first as 5 minus 4, the integral of 2 times f of x with respect to x, minus the integral between 5 and minus 4 of 3 with respect to x. And we know that, for example, if I have 2 times f of x, it's the same as saying 2 times the integral of f of x. If you have the integral of 2 times f of x, I can write that constant on the outside. So I can write this as 2 times f of x with respect to x minus the integral between 5 and minus 4 of 3 with respect to x. Now this we can use now our previous answer because I've written this down now. Whoops, I got the wrong thing there. I wanted this. Okay, so I've got this now exactly the same as that. So I can now replace this by 19.3. Okay, so I can now write this as 2 times, this is 19.3. And now I can integrate 3 with respect to x. That's going to give me 3x, right? So I'm going to have basically 3x between 5 and minus 4. Right, so 2 times 19.3 is 38.6 minus, now 3 times, I'll keep this in a bracket, keep it safe on the minus sign, 3 times 5 minus, and you have 3 times negative 4. A bit careful. What I would suggest is you keep this bracket here, and then we calculate what this is here, so to protect it from this minus sign out there. So you have 3 times 5, which is 15, and you got minus 3 times minus 4, which is plus 12. So you end up with 38.6 minus 27, which is going to give you, I think that's 11.6. 11.6. Okay, we can check that, make sure. So 38.6 minus 27, and that gives us 11.6. Okay, so we know that we're correct. So that completes this question from the June 2024, the paper 2, Pure Mathematics, the R paper from Edexcel International A-Level. Other questions from this paper can be found in the playlist that would appear on the top right of this screen. Other questions from the topic of the trapezium rule from P2, you can find them in this particular link here, the playlist for that, and you can subscribe to the channel by clicking on this link, and the video up here will tell you how to use my channel to find what you're looking for. Thank you for watching and see you soon.